A warm welcome to all my dear friends and students. This is the DADM, which is Data Analysis and Decision Making 1 course under the NPTEL MOOC series. And this course, as you know, is for 12 weeks, 30 hours, 60 lectures, and each week we have 5 lectures, each being for half an hour duration. So, as you can see from the slide, we are in the 28th lecture. That means we are into the 6th week. So, 30 lectures would basically complete the 6th week. Just a few things which I thought it's almost in the middle of the course. I thought I'll let you know. Technically, it would have been best that if I had shared all these things during the 30th lecture, but this is a query from my part that how interesting the course is for you, for all those who are taking this course, whether you have understanding this and whether you are able to appreciate the content and you have checked the books which have been suggested. The reason is that many of the queries which are coming in the forum are based on things which are maximum of there are already discussed, and the explanations have been given, and also many of the queries which are arising are of, say for example, for the first week. So, we as a team from NPTEL side, myself as a instructor and the TAs, we want to basically inquire from your end if how things are there, how good or bad this course is going on, whether you are understanding it, whether the concepts are clear. Because whatever in a 30-hour lecture where you have assignments 6 weeks, we will be in the 6th week. So, 6 weeks of assignment would be coming up as you complete the 6 weeks. So, in the 12 weeks you will have 12 assignments, you will have question papers accordingly. So, I think it is pretty well spread over where you will be able to read the concepts, answer the questions and clear your doubts. But main thing obviously happens is that in this duration of 30 hours to basically give the whole gamut of statistics from the data analysis and decision making point of view may not be possible. So, I will urge that students please read the books which I have suggested. They are, I am not saying they are the classic books, but they are quite adequate enough which will basically clear your doubts. And then if you can basically ask questions, obviously you have full right to ask questions from what is being taught, plus you can ask questions related to the books giving the references. It will be easy as for us to clarify the points, because maximum the queries which are based to the fact that they are little bit older discussions which we thought would be immediately raised, or they are queries that which may not be directly pertinent to the course. So, this is an earnest request from my part, and I am sure you will be able to take care of that, and we will be able to deliver the course in the coming 6 weeks in much better way. So, as you know, as I do mention each and every time, so we are in the 6th week and I am Raghunandan Sengupta from the IME department IIT Kanpur with this teaching this course. Now, the issue what we were discussing the last class, which was in the 27th one, was to do with the concepts of forecasting, the concept of trend analysis, concept of seasonality, cyclicity, and the models of halt linear, halt winter. They are the one of the so called adequate models which are able to take care of all the trends, seasonality, average movements and all these things, plus the concepts which I have discussed for regression part. They are also able to take care of your queries in a better way. Now, I did mention that I will be discussing the problem from multiple linear regression, but multiple linear regression would be more from the point of view of multivariate statistics. So, I will come to this concepts of problem solving for multiple linear regression a little bit later. So, this is a slight bit change in the overall plan, but it would not basically stop the flow. The flow it continues remains the same. There would not be any loss of knowledge, neither loss of the break of the continuity or the break of the concept which you are going to pick up. It is just a different change or where it should be adequately placed. Now, in the last part of the slide, which I will again discuss today, because generally whatever a slide I do for any class or any lecture, I complete that and then go to the next slide in the next day or in that same lecture, but this slide would be a little bit important because we will be discussing about normality in greater details. Now, if you remember, the concept of normality was stated by me during the course when we are discussing the normal distribution, x being normal with mean mu and sigma square variance. Then we also discussed that how you could convert x, which is a normal distribution, to the z distribution case, standard normal. And we also considered that later on that considering the central limit theorem to be true, we can consider any distribution with its mean and variance and plug it as the mean and variance, not plug it literally, they would be conceptual change how you do that. If you remember the mean values of that particular distribution, variance of that particular distribution, that their sample counterparts would be utilized, and we will basically be able to solve this accordingly for both the interval estimation problem as well as the hypothesis testing problem. Now, for the normality test, generally we have a very simple concept which is known as the QQ plots, which is the quantile plots. Now, the quantile plots concept is like this. As required, I will be writing many things, drawing many diagrams, as I generally do for different slides when I am discussing. So, the quantile plots, the issue is that you want to basically plot two different distributions, one being the standard normal, other being the unknown distribution. Compare the quantile plots and basically say whether that particular distribution which you are trying to compare with the standard normal distribution is normal or is skewed to the left or skewed to the right. Now, whether it is skewed to the left or the right would come up very nicely when you have the diagram for the QQ plots and when I discuss that accordingly. Now, the QQ plots conceptually is that you basically plot both the distribution, as I say, and you plot and you first rank them and then plot. So, what is going to happen? I am going to basically discuss it accordingly. So, we need to, this is the slide which we have missed, which we have not missed, we have did cover, but we are going to cover it again in order to basically clear the doubts in much better fashion. So, we need to check for the normality of x's and the normality of y, and one of them we consider to be at the standard normal deviate, and based on that we will proceed. So, you list the observations in the column number 1. So, you list the number 1, number 2, number 3. So, that is basically the serial number. So, let me try to do it accordingly. So, this is the first time I am trying to basically do the problem accordingly. So, it will be easier for all of us. So, I will switch over from the PPT slide to the Excel sheet for better understanding. So, I will not be going to the view mode, please excuse me and please appreciate how I proceed. So, list the observation number in the column 1 and call it I. So, this is 8th column and consider this is the I. So, I have the reading number. So, reading number consider I plotted. So, there is 1, 2, 3, 4, 5, 6, all these values are given. Now, list the data in column 2. So, we do not have any data. So, we consider, let us take, if we have okay, let us assume some data, arbit data, and we will use that data and corresponding to based on that we will try to see. So, consider the data is, I am putting an hypothetical arbitrary data. This will become clear as we do it later on. I should do it still 20. Let me make it very simple for ease of understanding. So, this is the data which you have. So, this is, let me write it, the data. So, this is column 2. Sort the data from the smallest to the highest and place it in the third column. So, now what you do is that copy it here first, now you select it. So, you go to sorting smallest to the highest, you continue the current list, and this is basically the values. So, data sorted 1, column 3. Then you, for each ith of the n observation. So, n you know, n is basically 20. So, let me write it down. For each of the ith observation, n observation, calculate the corresponding tail area of the standard normal deviation following this formula I minus 0.375. So, this would be is equal to I means it will be the data number which is here minus I minus, okay. So, this would be I is here minus 0.375 divided by n is, let me make it n coming from here, plus 0.25. So, what I do is that, because sorry. So, this is has to be being given a dollar sign because that is fixed. So, I copy it all the values. So, just check. So, the formula remains the same. Just check where the I am just highlighting it in order to make you understand that we have done it correctly. So, now use norm SNIV A. So, to produce a column of normal scores, put these values in. So, A column is basically this the data you have basically formed A. So, let me put it A. Now, put as norm SINV A. So, let me increase it. So, this is E is equal to, put the values in column 4, done, norm SINVA. So, norm SINVA is this NORM SINV. So, this is the value which I will take, put it. So, I copy it. Put this value in comment, mark a copy of the sorted data, to be sure use, so sorted data is this, in column 6. So, go done, make a scatter plot of this diagram. So, this is now I will explain that. Obviously, it won't be normal, won't be normal. So, what we have done is concentrate on these values. I will highlight it, make a different color scheme, that will be better. So, I will make it as orange, make it as light green. So, expand this. So, I basically switch on here, this is the one. Okay. Now, it actually what it is doing is this. If you concentrate on the orange column, starting values minus 1.86 till plus 1.86. So, these are the corresponding values on the z table or z distribution with the standard normal, whose overall CDF, that means from minus infinity to that value of minus 1.86, would be equal to the corresponding probability which we are getting when we find out the probability of having number 1 out of the total number of readings which is there in front of us. So, if I want to find out the corresponding probability of 1, so for 1, oh, I cannot write it here. Anyway, so let me use the, so let me note down these values minus 1.86, let me connect the 3 decimals minus 1.868 and 1. So, what I am doing is that let me make a tables blank sheet separately. Okay. So, that will be better. This is the extra slide we have basically inserted. So, let me go it here. So, what was the value? Value was minus 1.86. So, let me make the tables accordingly, and that value was 1. Only concentrate on this, things would become clear. Total number of values for the right hand side was basically 20. So, 1 would have basically a probability that it is being picked up from those 20 numbers. So, obviously, it will be 1 by 20 because there is only 1 1. Now, for this value of minus 1.686, what you do is that this is the normal distribution, this is the mean value which is 0, standard deviation is 1. Consider this minus 1.868 is here. I want to find out the overall area of z starting from total probability starting from minus infinity to that small z, which is I want to find out the probability of this one should be the case, where small z is so that would be equal to minus infinity to minus 1.868 f of z, sorry, my mistake, f of z dz, that will be equal to, let me use a different color. So, this is here, that technically should be equal to the probability, the sum of the total probabilities, not the probabilities, CDF, probability sum which is the CDF value of picking all, I am going to highlight this word, all numbers less than equal to the least value. So, consider those values I am ranking, consider them as y. So, So, y minimum till the value which is 1. Now, if I am changing, so this total, so this would be technically the CDF value. Now, if it is changing, consider these values. Here, consider the value of minus 0.744 and 12. So, there is 1, 2, 3, 4, 5, 5 values till 12 and the value is minus 0.744. So, let us come here again. So, it will be somewhere minus 0.744, this is 12, there are other values here, I am not including them. So, I use a different color, consider the green one, minus 0.744 is here. So, now the actual values with the sum of all these from minus infinity to minus 0.744. So, in that case the corresponding equation would be, I am using green color. So, in order to differentiate that. So, I am due to paucity of place I am basically space I am writing it here. So, please bear. So, is minus infinity to minus 0.744 f of z dz. This is not exactly equal, but it should be CDF value of this f of y, whatever the f of y is, we do not know. So, that will be sum of all probability starting one to 12. So, I will add up all the probabilities. So, probability of y is equal to 1 plus probability y is equal to, what was the next value? Let me check. Was 7, 8, 9, 12. Okay. 7, 8, 9, 12. Probability of 7 plus probability of 8 plus probability of 9 plus probability of 12. So, if add up all the probabilities and that probability which is the CDF, and that CDF would be exactly equal to, should be exactly equal to the CDF value for the standard normal from minus infinity to the value of minus 0.744. Now, actually what you are doing is a one to one correspondence, and what is that correspondence is, I will create another chart, another blank sheet and explain. I do not want to erase this, just pay attention here, and I will request that if the focus is there on the slide, and it will be much easier for me to explain. So, what we are doing is that trying to find out the CDF values starting from minus infinity to that value of z. So, that z's we have already found out, and that if they are exactly equal to the CDF values for all the sum of all the probabilities starting from the least value of the distribution to that value of the value realized value of the distribution, we will basically have, if there is a one to one correspondence, and then the QQ plots would be a straight line, 45-degree line. I am going to come to that later on. So, what we are trying to do is, so this is actually what is the essence. So, what we are doing, the summation from minus infinity to some value of z, f of z, this is the standard normal, that should be equal to f of y or small y, which is probability of capital Y being less than equal to small y. So, this is also equivalent to probability of small z less than equal to, so capital Z less than equal to small z. So, this is equal to capital of Z, small z is equal to capital of Y. This is what we want to ensure. Probability of y is equal to y. So, these are the CDF values. I should have written in a different color. Wait. For the diagram, I am going to do that. So, generally this is the CDF value for the, so technically is going to infinity. So, this is the z values, and this is 0, this is 1. So, that should have a 1-to-1 correspondence to another distribution which I have plotted. CDF values, I am trying to draw it as nicely as possible. CDF values. So, this would basically be y. I have a corresponding value of small y. So, the area which I covered up, there is a 1-to-1 correspondence which I am basically trying to highlight. And if you see, plot it, this one. So, this is not a QQ plot. So, if you see the one which you have drawn, so in this case it basically more skewed onto one direction, then goes straight and then changes the skewed direction. I will come to that this portions later on also. It is going to, I am going a little bit slow, please bear with me, and once I am going to utilize that for different type of distributions, it will be clear. So, the QQ plots would be discussed in more details later on. The slides which I have written, I am not going to delete them, let them be there. In the next class again I will basically start discussing that in further detail, so that it will be easier for you to appreciate what I have done and then try to basically use it your Excel sheet. It is very simple, just use the Excel sheet and double verify whatever I have said, and the results which you will get using exponential distribution or normal distribution in place of the RB distribution which I have plotted would give you good results in order to basically authenticate what I am saying is true. With this, I will end the 28th lecture and continue further discussion about the QQ plots in the 29th lecture and the subsequent one. Have a nice day and thank you very much.